Welcome to The Explainer. Today, we're going to talk about a whole family of materials that are absolutely essential to modern life. I mean, they're in everything from the planes we fly in to the coins in your pocket. They're literally everywhere. But what's so fascinating is that they're defined by what they're missing. We're about to step into the world beyond iron.
Okay, so just think about this for a second. You've got airplanes, you've got the electrical wires in your walls, and even the pipes under your sink. What on earth do they all have in common? Well, it turns out they all depend on this special class of materials, and the weird thing is, they're defined by what they aren't.
And the answer is non-ferrous metals. The definition here is just so simple, it's almost elegant. A metal, or an alloy for that matter, is non-ferrous if it just doesn't have any real amount of iron in it. That's it. And this one simple rule opens up this huge category of materials with some seriously incredible members.
And just to give you an idea of how massive this category is, get this. Pretty much every single pure metal on the periodic table is non-ferrous. The only exception? Iron itself. So yeah, we're talking about copper, aluminum, zinc, lead, silver. I mean, the list just goes on and on.
All right, so let's get into the good stuff. We're going to meet two of the biggest superstars in the pure non-ferrous world. I mean, these are the fundamental building blocks that engineers and designers have been relying on for centuries.
First up, we've got aluminum. You've definitely heard of it. It's one of the most widely used non-ferrous materials on the entire planet. And its superpowers? Well, it's super easy to shape, it resists rust, it's a pretty good conductor of energy, and, this is the big one, it's incredibly, incredibly light.
And you can see how those properties translate directly into its most famous jobs, right? I mean, think about airplanes or high-performance cars. Being lightweight saves a ton of fuel, and resisting corrosion just means the parts last way longer. It's just a perfect match of the material to the mission.
All right, next up, copper. This is another absolute cornerstone of the material world. And you'll probably notice some similarities to aluminum. You know, it's also easy to shape and resists corrosion. But its key talent, its real claim to fame, is being an excellent conductor of both heat and electricity. Not just good, excellent.
And this really shows you why copper is literally woven into the very fabric of our homes. So its resistance to corrosion, that's why it's perfect for water pipes. Its amazing conductivity, well, that makes it the undisputed king of electrical wiring. And that same fantastic heat conductivity is exactly why all those fancy, high-end pots and pans are made of copper.
Okay, but what happens when the properties of just a pure metal aren't quite cutting it for the job? You know, what if you need something stronger, or harder, or maybe something with a very specific melting point? Well, that's when things get really creative.
This is where engineers turn to alloys. And honestly, the best way to think about it is like cooking. You take a base metal, let's say copper, and you mix in another ingredient, another element, to create a totally new material with better or sometimes completely different properties. You're basically creating a custom-made supermetal. Let's look at a real-world example. So you take copper. On its own, it's got a pretty decent level of strength, but you add a little bit of tin to the mix and you create bronze, and the difference is just incredible. I mean, bronze isn't just a little bit stronger, it is a completely different beast. It's hard, it's brittle, and get this, it even resists metal fatigue better than steel.
And you know, this simple idea, just mixing metals together, has given us some of the most important and recognizable materials in all of human history. We're talking about materials that literally shaped entire ages of civilization.
Two of the most famous non-ferrous alloys are perfect examples of this: brass and bronze. They both start with the same primary ingredient, copper, but their recipes create totally different results. You add zinc to the copper, you get brass. You add tin instead, you get bronze. Same starting point, two very different materials. So what this means is that alloys aren't just alternatives. A lot of the time, they are superior for specific jobs. We all kind of think of steel as the ultimate tough guy, right? The strongest material. But bronze actually resists metal fatigue and, this is huge, seawater corrosion way more than steel does. And that's exactly why, for things like ship propellers or underwater fittings, bronze is still the king.
And this whole world of alloys is part of our daily lives in ways you might not even realize. Let's take something super common. Money. Yeah, you might actually be surprised by the cool metallurgy that goes into the very coins in your pocket.
So, for example, those British silver coins, they aren't actually silver at all. Nope, they're a really clever alloy called cupronickel. It's mostly copper, about 75%, mixed with nickel. And what you get is this durable, corrosion-resistant blend that looks the part, but without the crazy high cost of using real silver.
And cupro-nickel is just one example out of countless specialized recipes. By adding elements like phosphor or silicon or even aluminum to a base metal, engineers can cook up a whole universe of different alloys. Each one is precisely engineered for a very specific job, from, say, phosphor bronze that's used in high-wear gears to gunmetal that's great in corrosive environments.
So when you look at it, this whole journey from simple, pure metals to these complex, custom-made alloys, it really tells a story about human ingenuity. But it also makes you wonder, right? What does this constant search for the perfect material actually mean for our future?
I think the key takeaway here is just how elegant this whole process is. It all starts with really understanding the basic properties of the pure elements. Once we know what each one brings to the table, we can start mixing and matching them just like a chef with spices to engineer brand new materials designed to solve the challenges of tomorrow. And that really leaves us with a final thought to chew on. For literally thousands of years, we have been perfecting this art of mixing metals. So if this is what we've been able to do with just the basics like copper, tin, and zinc, just try to imagine what new combinations and really what new worlds we're going to create next.